Hi everyone, we are going today to simulate a circuit with 3 loops using Multisim software. We are going to simulate something that looks like this, but we are not going to stick with these numbers, just to explain the general concept. So basically this is a circuit with 3 loops. What we are going to do is we are going to get resistors and sources. So from basic, if we click on select component from either here or here, but preferably here, select component, go to basic, and then go to resistors, and then we select the resistor that with the desired value. Right, so what if I don't want the 1K resistor? If I want, for example, the 2K resistor, just change it, double click and change the value of it. Just in case you want to be more realistic and add more realistic resistors, go to tolerance and click on 5 or 10 or whatever tolerance that you may have. So again, click on select component, basic resistors, and maybe get another resistor with different value. Here. Now to reduce the process of clicking and selecting, you can highlight these 2 resistors, Ctrl C for copy, Ctrl V for paste, and paste your resistors somewhere in your circuit. Now this resistor is laid out horizontally. By right-click on it, you can click on flip clockwise or anti-clockwise, depends what you want, or Ctrl R. If you press Ctrl R, it will automatically change the orientation of these resistors. Okay. Now let's connect some resistors together. I just connected all these resistors together. It's time to put the source. We go to click here, which is select component, we choose source, and then we go to power supply or power sources, and we select the DC power, which is basically, it's a battery. Okay, now we have a complete circuit with 3 loops, and it is ready now for measurement. So we click run, and then the circuit is running, and there is a current. There are some currents flowing. However, we can't see them. So in order to see them, we have 2 methods. Either we click on the multimeter here, and since we connect the multimeter on series, so we need to break the circuit and then connect the multimeter as follows. There's a nice way to measure the current, which is the props. You can put a prop here. You can right click and to change the direction of the prop. So reverse prop direction, double click on this yellow script, go to parameters, custom, in order for you to only show, for example, one value. You are not interested in peak to peak and so on. So click on this, run it. We got 12 nano amps, and that's, yeah, we should not forget to click on A for the multimeter. So we go here 4.299 milliamps, and this is 4.3 milliamps as well. Now in order for us to measure the mesh current, the mesh current is the same as the branch current. However, the branch should not share any loop with another circuit or another loop. So basically this is a branch, which is a mesh current. This is a mesh current as well. This is a mesh current. So again, we like copy paste. So copy, paste, another copy paste here. So we have 3 mesh current flowing around. So this one has this value, this one has this value, and this one has this value. Now in order to measure the voltages, we can choose the prop here and another prop here. So again, if we don't like this one, you only, sorry, yeah, again, custom, so no, yes. Now we are measuring the node voltages. Okay, only when we are working with nodal analysis we use this tool. I don't recommend it usually, because this gives you a misleading result. Now if I put, when we do nodal analysis, we need to refer to one node as the ground node. We refer to it as 0. If you notice here, it's 4.3. If you run it, well, it did not change now, but normally it changes now. But the best method to measure the voltage across a resistor is to use a multimeter, because the multimeter will measure you the voltage difference. Okay, you can as well measure the voltage here and subtract from here, or vice versa. It gives you the same value. However, if you are using nodal analysis, you must ensure that you put a voltage, a refer, or you attach a ground to one of the reference node. And the voltage difference here is 870, which is basically 5.17 minus this should give you 6. How much is this? That's 60 plus, that's 77 or 770. Yeah, I just used my phone calculator. Yes, it is actually 870 millivolt. And that's it. I was hoping to finish this in 1 minute, but it finished in 6 minutes. So I'm going to put a suitable subject for my video. Okay, thank you for watching. Thank you very much. Bye.